In this video, I want us to look at position vectors. We'll start with a definition for position vectors, and the question is, what are position vectors? So position vectors are vectors whose starting point is the origin. So what you have is the xy plane. Here is the xy plane. Okay, so suppose you are given the coordinate A. Let's say this is 1, and then here you have a 2, then here you have 1, 2, and then you have a 3 there. And let's say you are given the point 1,3 here, A, 1,3. So if the point is 1,3, then the position vector for the point A is a vector whose starting point is from here, from the origin. And so what we are going to have, a vector which starts from here all the way up to here where A is, with an arrow pointing in that direction. So this vector here is actually the position vector for the point A. And so we usually write it like this: OA with an arrow which shows the direction is equal to 1 and a 3. So this is how you write this point as a position vector. And so position vectors, like we said earlier, are vectors whose starting point is the origin O. Now let's have another point. Let's say B, which is given as 2,1. Okay, so 2,1, 2 is here, 1 is here, 1 is there. So you have B here. Okay, so the position vector of the point B, which is 2,1, will start from the point O, going in that direction with an arrow. And so you can write it as OB with an arrow on top is equal to 2, 1. So here we always start with 2 here and then the 1 down. And so this is a position vector. So this is a coordinate. This one here is a coordinate. And then this one here, OB, is the position vector. Position vector. So this is the position vector of this point that we have. And so as you can see illustrated by the diagram here, this is the x-axis here, and that is the y-axis there. And so these are what we call position vectors. Now, when you are given two position vectors, OB and OA, normally we will ask questions on this vector here. We'll ask you to find the vector AB, for example. So, for example, if we ask, okay, can you find the vector AB? Find AB. Okay, so when you're finding the vector AB, just by looking at what we have here, you can see that actually you can write a vector equation for this. And the vector equation is going to be, so AB simply tells you that you have to start from A, and then you move around this triangle all the way up to B. So you're going to have A to O plus O to B. Okay, so since our arrow is pointing in that direction for OA, so this one here, AO, can also be written as negative OA plus OB. Okay, so when you look at this here, you can also write it as, by starting with OB, this is OB minus OA. So in short, what I'm trying to show you here is that the formula for AB in position vectors, like what we have here, AB is actually OB minus OA. So this is a very important vector equation here. When we start answering questions on on vectors, on these position vectors, you find that this formula is very important. AB is equal to OB minus OA. So you have to remember this one, the one that we have derived from this diagram that we have. Now let's look at some questions on these position vectors. Okay, so here are some questions that we have on these position vectors. Okay, so we have these questions here. Now we are going to look at these two questions that we have. Okay, so the first question here says, given that A is 2, -5 and B and OB is the vector 3 and 9, find the magnitude of AB. Find the magnitude of AB. So we are going to find the magnitude of AB. So A is the point 2, -5, and then we are given the position vector for B, which is given as 3 and 9. Okay, so this is our first question here. So now the question says find the magnitude. So these two lines here are asking you to find the magnitude, the size or the length of the vector. And so there's a formula that we use for calculating the magnitude of the vector. The formula will be given later, but the first thing that you have to do in this question is you have to find AB. And so write this A as a position vector. It's going to be OA. Remember, position vectors always start from O, the origin. So you're going to have 2 and -5 as a position vector, and then you also have B, which is given as 3 and 9. And so for us to find AB, we are going to use the vector equation, which we derived earlier, which is equal to OB minus OA. Very important formula, this one in vectors. And so we are going to substitute what we have here. So we have OB here, which is 3 and 9, minus OA, which is 2 and -5. And then we are going to subtract here. So 3 minus 2 is what we are going to do here, which will give us 1. And then 9 minus -5. So you notice that these two negatives will give us a plus. So it's 9 plus 5, which will give us 14. Okay? So now, after we have reached this stage now, we need to find the magnitude now. So the formula for the length of a vector, or the magnitude of a vector, is given by the square root of x squared plus y squared. Okay, so sometimes, like in this case, we'll need to use our calculators. So here, when you look at our vector for AB, the one that you are seeing here, this is the x value, and the 14 is the y value. So we are going to substitute in this equation here, which will give us the square root of 1 squared plus 14 squared. Okay, which will give us the square root of 1 plus, and then 14 squared will give us, let me just use my calculator here to find what 14 squared is. Okay, so 14 squared is actually 14 times 14. 14 squared. Okay, so this gives us 196. 196. And then we are going to add those two. We'll get 197. And then now we can find the square root of 197 by using our calculators. So here is my calculator. We are going to find the square root of 197 here. So the square root of 197, 14.035, and then which we can round off to 14.0 units. Okay, so question 2. In question 2, we have this question here, which says, given that AB is equal to 9 and -6, and B is the point 3, 2. So here's our question 2. Question 2. So AB is equal to 9 and negative 6. And then we have B, which is given as a coordinate as 3, 2. Find the coordinates of A. Find the coordinate of A. So the first thing that we are going to do in this question is to write this B as a position vector. So as a position vector, the B is going to be OB is equal to 3, 2. Okay, so after we have written this B as a position vector, now we are going to write the vector equation for AB. So AB is equal to OB minus OA. Okay, and then we are going to substitute now. So our AB is this one here, 9 and negative 6. Our OB is what we have here, 3 and 2 minus OA. Okay, so at this stage now we are going to collect like terms. So this 3 and 2 will come this side, and since it has a positive in front here, we are going to have a negative. So we are going to have 9 negative 6 minus 3 and a 2. And this side you are going to remain with negative OA. Okay, so at this stage now we are going to subtract. 9 minus 3 will give us 6. Negative 6 minus 2 will give us negative 8. And so we are going to have negative OA. Okay, so now at this stage now we have to get rid of this negative that we have this side. And there are so many ways of doing it. Okay, so we'll just follow one way. Remember that anything that you have as a coefficient of 1, so there's a 1 in front here. So we are going to divide both sides by negative 1. This negative 1 here, even here there's a 1, so you divide by negative 1. So that this negative cancels with that, you remain with OA is equal to, and then negative 1 into 1, there you have negative 1, 6, and negative 8. And then you can multiply this negative into all these numbers that are in the brackets here. And so you are going to have OA is equal to negative 1 times 6 is negative 6. Negative 1 times negative 8 is positive 8. And so since the question says find the coordinates of A, so you are writing the coordinate of A. So you've already found the position vector for A. So therefore, as a coordinate, you are going to have A is negative 6, 8. And this marks the end of our lesson. Thank you very much.